In this video, we are going to finish off on this chapter in statistics. So we start by looking at what we call the standard deviation. Now, the standard deviation, this is just the positive square root of the mean of the squared standard deviations from the mean. So we have these formulas over here that we use to work out the standard deviation, and we say that our standard deviation is equal to the variance squared. So that means if you have the standard deviation, if you have your standard deviation, this is the square root of the variance, and that also means that your variance is equal to your standard deviation squared. So if you know one, it's very easy to work out the other one. So this formula here, sometimes you can use this one over here, and you can see that with our standard deviation, if you just square both sides, then what you're left with is your variance. So this one, if I square it, so if I were to square this one, the square and the square root would cancel out, and then I would end up with this formula here. And this one, if I were to square it, I would end up with this one over there. So standard deviation is the square root of the variance, and the variance is the square of the standard deviation. So I can use either of the two formulas. You should still get the same answer. Okay. So now we want to look at an actual example of how to work out the standard deviation. So let me copy this. So what we're going to do is we're going to calculate the standard deviation and the variance using both of the formulas. And then, like I said, I'll show you how to do it on your calculator, because in the test, this will be maybe like 1 or 2 marks. So you don't have to use a long method if you can just work it out on the calculator. So the first formula, all right, the formula over here, it says that the standard deviation, this is the square root of the sum of x minus x bar squared divided by n. Okay, so for each of these, the x values, you have to subtract the mean from it and then square it and then add everything together. So we need to work out the mean. So x bar, so like I said, first I'm going to do it the long way and then show you how you can easily do it on the calculator. So to work out x bar, we just say this is 4 plus 6 plus 2 plus 0 plus 3 plus 5 plus 8. And this is all divided by 7. So I have 7 values. So this is 1, 2, 3, 4, 5, 6, and 7. So this we can do on our calculators. 4 plus 6 plus 2 plus 0, I don't need to say plus 0, plus 3 plus 5 plus 8 divided by 7, this gives us 4. So we have our mean is 4. Then what we're going to do is we are going to extend our table and include a column for x minus x bar. So I'm just going to move this one here. So we have x minus x bar. So we say 4 minus 4, this is 0. 6 minus 4, this is 2. 2 minus 4 is negative 2. 0 minus 4 is negative 4. And 3 minus 4 is negative 1. 5 minus 4 is positive 1. 8 minus 4 is 4. And like I said, if you've done this correctly, when you add all these values up, they should give you a 0. But we're not interested in that 0 value. Then the next thing is, if you remember, we said this symbol here, sigma, means a sum. But first we have to square it. So each of these values here, we're going to square them. 0 squared is 0, 2 squared is 4, negative 2 squared is 4, this is 16, this is 1, that is 1, and this is 16. So this is x minus x bar squared. Okay, and then the last thing is this summation. The summation just means you must add everything in the column. So we have our calculator with 0, 0 plus 4 plus 5. We have 4 plus 4 plus 16 plus 1 plus 1 plus 16. And this gives us 42. Okay, so our answer there is 42, and that is our numerator. And n is the number of data points that you have over here. So if we were to then substitute this, we have the square root of the summation of x minus x bar. This is 42, and we divide this by 7. So do this calculator, the square root of 42 over 7 is this the square root of 6, which is 2.449. Okay, that is our standard deviation. And from there, we can also work out our variance. Our variance will be equal to 6. So you just take this one and you square it because it's equal to the square root of 6. When I square this, I am going to get 6. So you can try that. It's my calculator. Square this. The answer is just equal to 6. So your variance is just the standard deviation squared. So this is our first formula. Now let's try it with the second formula and see if we are going to get the same thing. So this one here. So this is all working that we need to show. So I just want to move it for space. Okay, so the second formula is as follows. So this is formula number 1. So in a test, you don't have to use both formulas, just one of them is fine. Or as I will show you now, you can just do this on your calculator. So the formula is standard deviation. This is the square root of the sum of x squared divided by n minus the sum of x over n. This is just equal to the mean, actually, divided by n squared and then the square root. So notice that if I add all these points together, that's what the sum means, and then I divide by how many I have, that is actually the average. So this is the mean squared. Okay, so we can substitute. So this, in this table, x squared was computed for us. They took all the terms and they squared them for us. So the only thing we had to do is find the sum of the x squared terms. So that means you take all these terms here and add them together. But lucky for us, this was already done. So I just take the square root of 154 and I divide by 7 because there's 7 data points. And then the sum of the x's, so you take all the x's, this is 28 divided by 7, and then we square this. This can do on our calculators. We have the square root of 154 divided by 7 minus 28 divided by 7 squared, And you can see this is still giving us the square root of 6, which is the 2.449. And then again, if we wanted the variance, we just take the standard deviation and square it. So it doesn't matter which formula you use, whether you use this one here or you use that one there, you will still get the same answer. Now, like I said, here, because there's only 7 points, working out this whole table is not that difficult, but of course there is an easier way. You can just do this, type this in on your calculator, and then get the answer. So if we do that, I take my calculator. We have to go to stat mode. So we go mode, and then stat mode is number 3, that's for statistics. And then we choose option 1, which is one variable. Then these x values, we're going to input them one at a time. So we say 4 equals 6 equals 2 equals 0 equals 3 equals 5 equals, and the last one is 9. Oh, no, wait, the last one is 8. So if I made a mistake, you can always just go up. It's supposed to be an 8, so I just now type 8 and I change it. Then you can always check. The first one is 4, then 6, and then if you need to change it, then you just type in the correct number and press equals 2, 0, 3, 5, and 8. Then you press on. Now, on your calculator, it can work out the standard deviation for you. So like in our test on Saturday, I'm not really interested in the working. I think we say find the calculations on your calculator. Of course, you can do the long method, but those questions are like 2 marks. So you'll be spending a lot of time drawing these tables when you could just do it on a calculator. So to find our standard deviation, here we can go shift and then stat and then option number 4 and then our standard deviation. So number 3 and number 4, both of these are standard deviations. The difference is this one refers to a standard deviation of a population, and this one refers to a standard deviation of a sample. So population means you've included all the data, and then sample means some of the data points you have not included. But you can see that I included all my data points, so I pick this one. So number 3, and then equals, and there it is. You can see the answer is the same for all of them. Okay, so that is my standard deviation. And you can even use the formula itself, like this one here, but get all these values on your calculator. So to do that, I'll show you. Let's say we just have the formula. We want to use the formula ourselves. So we have standard deviation. This is the square root of the sum of x squared divided by n minus the sum of x over n. This is squared. So we can work out, we know that n is equal to 7 because there's 7 data points. Then we can write out what is the sum of x squared. So from our table, we can see, here it is. It was 154. So we want to see, can we still get the 154 on the calculator? And then we have the sum of x, which we know from here is 28. So let's see if we can get these values from the calculator and then just do the substitution just to show that we did some calculations. Okay, so when we do that, we go again, shift and stat. And here, because we're looking at summations, then we choose option number 3, which is a sum. So we have the 2 options, number 1 equals, and there it is. It gives us 154. And then this one here, back to our calculator, shift, stat, option number 3, and it's this one, number 2. equals, and this is 28. And then just to show that we've done some calculations, I'll take these values that I got on my calculator and I'll just substitute this one here. This is 154 and my n is 7 minus this one, the sum of the x's. This is 28 over 7 squared, and I will still get the square root of 6. So that is much faster to do than if you were just working it out individually or doing all the calculations yourself. But you can use whichever method you prefer. So when the data is grouped, we use a similar formula. So with the group data, the formula is a little bit similar. We just need to remember it. Okay, if we wanted to use our calculators for this one here, it's a little bit different. So I would stick to this one because when we have group data, we're usually not going to have like a lot of groups. But the formulas, as we can see here, they are very simple. So we have the sum of the frequency multiplying by x minus x bar. So we have to calculate x bar. We did this in class yesterday, how to calculate the mean of grouped data. And this is divided by the total frequency. Okay, and then of course you can break it up like this. So the formulas are a little bit similar. If you look at the first one here, and you look at the other one, all that is missing is you need an F there instead of an N. You have the total frequency and the same thing over there. So I just very quickly want to go over this one. Since it's done for us, I'm not really going to do it. But if you understand how the table is constructed, then you will be able to work it out on your own. So here, most of the time, what you will be given is these two columns here. You have your classes and you have your frequency. Then what you will be asked to do is to work out the midpoint. So you will have to work out the midpoint because you need the midpoint in order to work out the mean. Okay, maybe let's do that. Let's say so this is what we are given. Then what we need to do is work out our midpoints. Okay, so working out the midpoints is fairly easy. We just take the upper limit minus the lower limit, upper limit plus the lower limit, and then you divide by 2. So you'll say 5 plus 0 is 5 divided by 2. This gives us 2.5. So then we say 10 plus 5 is 15. 15 divided by 2 is 7.5. 10 plus 20 is 30. 30 divided by 2 is 15. 40 plus 20 divided by 40 plus 20 is 60. 60 divided by 2 is 30. Okay, and then here, so this one, we don't have an upper limit. So I'll just refer to what is given to the table and say that the midpoint is 50. because I want our answers to be uniform. So in a test, I wouldn't just say over 50 either. I will give you the midpoints it's themselves when I say 40 and over, because I can't ask you to just calculate and then you guess. Some may say, okay, is it 40 to 60? Some will say, is it 40 to 50? And so on. So we'll get a lot of confusing answers. So we just go with the one that is given to us on the table. So now the formula that we are going to use, there's two of them, and whichever formula we use, remember, we should get the same answer. So let's start with the first one. So the first one says this is the sum. So we have the square root. So remember, this is all the standard deviation. This is the square root, big square root of the frequency multiplied by x minus x bar squared over the sum of the total frequency. Okay, so we just need to work out our x bar. So x bar, we know that for group data, we take our midpoints multiplied by the frequency. So this is the frequency multiplied by the midpoint, and then we add them all together, and then we divide by the total frequency. We divide by the total frequency. So doing that, we say 4 multiplied by 2.5 plus 9 multiplied by 7.5 plus 38 multiplied by 15 plus 33 multiplied by 30 plus 16 multiplied by 50. And this is all divided by our total frequency is the sum of all of these. So we can work this out. This is 4 plus 9 plus 38 plus 33 plus 16. And this gives us 100. Okay, so this is what we have, and we can work this out. Let's see. We have 4 times 2.5 plus 9 times 7.5 plus 38 times 15 plus 33 times 30 plus 16 times 50. And this gives us 2,437. 7.5. So as far as possible, don't round off too early. And then when we divide this by 100, the decimal just moves. Don't need a calculator for that. So we have 24.375. So just use it the way it is instead of rounding off. Then you can see here, it's saying x minus x bar. So that means for each of the points, the midpoints, you subtract the mean. You subtract 24 point, this one here. Okay, so you'll say 2.5 minus 24 point, this one, and so on. So we start 2.5 minus 24.375. This is negative 'over here. This is x minus x bar. This is 21.875. Okay, then the same thing with this one here. We have 7.5 minus 4.375. This is negative 16.75. Then we have 15. We have negative 9.375. And then next we have 30. This is 5. And then we have 50. Okay, so just check my calculations, make sure they are correct. Okay, so this is what we have. So we have just this part over here. Let me highlight it in red. So we've done this part here. Now the next thing is we need to square it. So we have x minus x bar. So we take each of these and we square them. So we have negative 21.875. Let me square this. Okay, need brackets here, otherwise it'll come out negative like this. But we know our answer should be positive. So it should be negative 21.875. Here we have, I think to 4 decimal places is fine. We have 478.5 5625. So we always want to avoid rounding off, but sometimes we have to. Okay, then next we have 16.875. So because I don't have 16. So because it's negative and you're squaring it, the answer is going to end up positive. So that's why I'm not even bothering with the negative sign. So this is 284, 16, okay. 284.765 625. Then the next one, we have 9.375. When we square this, we get 87.89, 0.625. Then we have 5.625. When we square this, we have 31.64. And here we have 0.625. And then finally 25.625. When we square this, we get 625. 625, 656. Six four 0.625. Okay, so you can see a lot of work to do. Yeah. Then, so the other formula might be much faster than this one. Then the next thing, if we go back to our formula, here we have to multiply this one times what we have here. So we take our frequency and multiply here. So we have 4 times this one. I think now I need to just round off. So we have 4 multiplied by 478.515625. This gives us 1914. So this is f multiplied by x minus x bar squared, 0.0625. Then the next one, I have 9 multiplied by 284.765625. This is 2562. Okay, then the next one, I have 38 times 87.890625. This is 375, and then 33 times 31.640625, 1044.114. Okay, and then the last one, I have 16 multiplied by 656.640625. This is 10,006.25. Okay, and then you can see now I just need to add everything together. So you take all these and you add them together. So we have 1914.0625 plus, this one here, I didn't put my decimal. What was the answer supposed to be? Okay, so it was, so I have 9 times, so it's this one times that one. So 284.76565. Okay, so the decimal should be here. Okay, and then I have a decimal here. Okay, let's try it again now. 1914.0625, 2562.890625, 3339.84375, 1044.140.625 plus 1056.25. Okay, so I have 19,367.1875. Now that's the numerator over here. And that I have to divide by the total frequency here, which is just equal to 100. And then take the square root. Okay, so my standard deviation, this is the square root of 9367.1875. We divide this by 100. Okay, so on our calculators, we have our answer. We divide this by 100, and then we take the square root, and that gives us 13.9, which is exactly what we have. So this is 13.919166. So if we look at this one here, that is exactly what they got. So remember, these are in hundreds of hours. So 1300 hours is 1,390 hours. And this was done with the other formula. So whichever formula you use, you should still get exactly the same answer. So that is on the standard deviation. Then we also have what we call the standard error. So the standard error reflects how much sampling fluctuation a statistic will show. And the size of the standard error is affected by two values. First one is the standard deviation. A large sigma, which is the standard deviation of the population, leads to a larger standard error and also the number of observations. So our standard error is just equal to the standard deviation divided by the square root of the sample size. So the bigger the standard deviation, the bigger the standard error, the bigger the population, then the smaller your standard deviation because you are dividing. Now here, we're given this data over here. And of course, this can be a good exercise for you to do. I'll just give you the answers so that you can see if what you are doing is in fact correct. So the mean deviation, if you remember our formula, send our notes over here. It is this one, the summation of the absolute value of x minus x bar, which is the mean over n. So this is our formula. This is the summation of x minus x bar over n. Okay, so I've worked it out for this one here. Let's see, what should I get? In the numerator here, I got 310, and here there is 30. So I got 10.333. Okay, continue. So you should try and work it out and see if you're getting the same thing. Now, standard deviation, I already entered it in all these into the calculator, so I can just work out my standard deviation, shift, and then for standard deviation, option number 3, and I'm getting 12.413. So this is 12.413. And the standard error, now this is equal to the standard deviation divided by the square root of n. So our standard deviation, 12.413, and we divide this by the square root of 30. So we just take this one and we divide by the square root of 30. Okay, so our standard error is 2.266. Okay, so try and work it out on your own and see if you are getting the same answer. Now, the next thing we look at is correlation. So with correlation, we want to see if two variables, x and y, whether they go together. So we ask ourselves, if the first variable x has high values, does it mean that y also has high values? That would mean that there's a positive correlation. Or if x has high values and y has low values, then there's a negative correlation. But sometimes it is possible that there is no correlation at all. So some things are related. So maybe things like unemployment and crime, the higher the unemployment, the more the crime. So those you would expect a positive correlation. And then negative. Then a negative correlation, maybe I can't think of one, but I'm sure you can think of some that when you think about it, there is a negative correlation. So that means when one goes up, then the other one, that one has high values, then the other one has low values. Maybe like income and crime. I don't know if that is necessarily a good one. Like if people are getting more money, are they more likely to commit crimes and stuff like that? So it's not a very good example, but you understand what I'm saying. All right, so here is an example. So it says that assume you want to determine whether there is a relationship between the number of sales calls made in a month and the number of copiers sold. So does it mean the more calls you make, then the more copies you are going to sell? So you take the data from these sales representatives, then you ask them how many sales calls did you make and how many copiers did you sell. And then we want to see if this is our X, this is our Y. Does it mean if X is high, Y will be Y, well, Y will be high, or if X is low, does it mean this one will be high, and so on? Or is there no relationship at all? Okay, now the first way to try and see, like to get a visual representation of the correlation is by using what we call a scatter diagram. So what we do is we plot these values here on the X and the Y axis. So our sales calls will go on the X-axis and this one will go on the Y-axis. So the first one, we have X is 20, Y is 30. So we go and we plot it. X is 20, Y is 30. Then we plot it over there. Then we go to the next one. We have 40 and 60. So X is 40, then Y is 60. Then we go to the next one, 20 and 40. So we have 20 here and we have 40. So we just plot each of the points and then we want to see how is this data distributed. So that will tell us whether we have a positive correlation, a negative correlation, or there is no correlation at all. So here we can see that there is maybe like an upward trend. So here, this is how we interpret our scatter diagram. So if you were to plot the points and then you notice that they're lying in almost a perfect line, then we say that there's a perfect positive correlation. So when the X values increase, then the Y values also increase. This one here, they don't fall in a perfect line, but you can see that there's some positive correlation here and it's quite high. We say it's high because there isn't that much space between the dots. This one here, you can see there is also an upward trend. So this one would draw what we call a line of best fit. That is a line that passes through most points. Obviously, mine is not the best one because it's hard to draw on the computer. And then here you can still see there is some positive correlation. It's not as good as that one because the points, there's a lot of gaps between the points. And this one here, this just look like random dots placed all over the place. You can't really say it's going up or going down. So this one, we would say that there is no correlation. And here there's negative. There's definitely a pattern going downwards, but because there's so much spaces there, then we say it's a low negative correlation. And then this one, clearly downhill, there's a high negative correlation. And this one, it's almost perfect. And we have these numbers here. When our correlation is a 1, then it's perfect. 0.8 around there, it is high, positive. 0.3, that is a low, and 0 means there is no correlation. And then negative values also the same. So we can work out these numbers over here, and that will tell us about the correlation of our variables. Okay, so what tells us about our correlation is actually what we call the correlation coefficient. So we have a formula that we use to work it out. But of course, this correlation factor, you can work it out on our calculator, and I will show you how to do that. But we have a formula over here. This is a formula that you need to remember, and it's not that difficult to remember. We have SSXY, so just say XI minus the mean, every Y minus the mean, you multiply them, add them together. And then in the denominator, we have X minus X bar squared, and then we also have this one here, which is Y minus Y bar, and then we square it. So we can work this out, but of course, like I said, this we can also do on our calculator in just a few steps. So depending on what we get for our coefficient for our correlation coefficient, this we call it, this is a Greek letter. It is rho. Okay, so it looks like a P, but it is actually the Greek letter rho, and that is why we in English refer to it as R. So if our correlation, the absolute value is between 0 and 0.5, then there is some correlation, but it's weak. If it's between 0.3 and 0.7, then there is a moderate correlation. And if the absolute value is greater than 0.5, then there is a strong correlation. So whether it's positive or negative, we'll say it's weak positive, weak negative, moderate positive, moderate negative, or we'll say strong positive or strong negative. Okay. Right. Then here with regression, what we do is we introduce simple linear regression. So basically what we want to do is establish a relationship. So if we know that two of these variables, there is some relationship between them, then we can come up with an equation that we can then later on substitute values into the equation in order to work out more values. But when we look at an actual example, then we will go through that one. Okay, so that you can read through. So I don't want to do too much of the reading that you can do on your own. So here are some examples where you can use regression. So you want to test if IQ affects income. Is there a relationship between IQ and income, that the higher your IQ, the more your income will be? And then testing if hours of work affects hours of sleep. The more you work, does it affect your sleep? And so on. Testing if the number of cigarettes smoked affects blood pressure. So there's so many things that you could test using regression analysis. Okay, so I want us to do an example first of this one here, where we work out the correlation. Let's see. So like I said, we can do this on the calculator as well. So here, when you have two variables, we're going to do it slightly different. We go to our calculators and we go again to mode and stat mode. But this time, instead of one variable, we use this one. This is the equation of a straight line a plus bx. So we choose option 2. Then we take all our x values and we enter them. So we have 20. We have 40, we have 20, we have 30, we have 10, we have 10, 20, 20, 20, and 30. Okay, and then we go to the next column, and now we enter the y values. So we have 30, 60, 40, 60, 30, 40, 40, 50, 30, and 70. Okay, so there, and you can always scroll up and down and check, make sure you've entered your values correctly. All right, so we need to know if we're going to first use our formula and then we'll check what the calculator gives us, make sure we have done the correct thing. So our formula for R, this is S xy over the square root of SSXX SSYY. Okay, so SXY, this is the sum of x minus x bar squared multiplied by x minus y minus y bar. So this is what we have. Okay, so for each of these, we need to work out what is our x bar. So this we can just do on our calculator. Again, we go mode, and we have, sorry, not mode, shift rather. So we go to shift and stat, and then we go to our variance number 4, and you can see here there's more options. We can find x bar and we can find y bar. So 2, this is 22, so x bar is equal to 22, and then y bar or y bar is option number 5. This is 45. Okay, then from each of these values, we are going to say the mean, x minus the mean. Okay. So we say, so I start with x minus x bar. So I'm just trying to save space. So I say 20 minus 22, this is minus 2. 40 minus 22, this is 18. 20 minus 22 is minus 2. 30 minus 22, this is 8. 10 minus 22, this is minus 12. Here we have minus 12. And here 20 minus 22, this is minus 2, this is minus 2, this is minus 2, and this is 8. Okay, so just a quick check, make sure that everything is in fact correct. X minus x bar, 40 minus that one, 20 minus 22, 30 minus 22, minus 22, minus 22, minus 22, minus, okay. All right, so this is our x minus x bar. And then over here, we can work out what is y minus y bar. So we say 30 minus 45, this is minus 15, this is 15, this is minus 5, this is 15, this is minus 15, this is minus 5, minus 5, we have 5, minus 15, this is 25. Okay, so we have all our x minus x bar. So starting with this one, we have to multiply each of these and then we add them together. So this one times this one, plus this one times that one, this one times that one, and so on. So this is minus 2 times minus 15 plus 18 times 15. I think it would be easier if I did this in a table. Okay, but it's fine since I've started already. Then I have minus 2 times minus 5 plus 8 and 15. And then I have minus 12 and minus 15. And then I have minus 12 and minus 5. Then minus 2 and minus 5. Then minus 2 and positive 5. And then it is minus 2 and minus 15. So here 2 and 25. Okay, so I just hope I haven't made any mistakes, but I'll do this on my calculator anyway. Okay, so I have these two, they're both negative. So sometimes I won't write the negative because I know that two negatives, when I multiply them, they give me a positive. So I have 2 times 15. Then I have 18 times plus 18 times 15. Then I have 2 and 5. Then I have 8 and 15. Then I have 12 and 15. I have 12 and 5. Then there is 2 and 5. Then there is -2 and +5. So that one I need to have a negative answer because this one is negative and that one is positive. And then I have 2 and 15. Then I have 8 and 25. And my answer is 900. Okay, then I need to work out SSXX. So this one we know is equal to the sum of x minus x bar, and you square them. So each of these you square them and then add them together. So I'll just show you on the calculator and not really write everything. So I have 2 squared, because -2 squared is the same as 2 squared. And then I have 18 squared, I have 2 squared, and then I have 8 squared, I have 12 squared, and I have 12 squared, and I have 2 squared, and 2 squared, and another 2 squared, and then I have 8 squared. So I hope I haven't made any mistakes. So this gives me 760. Then SYY is a sum of y minus y bar squared. So each of these values, you square them and then you add them. So I have 15 squared plus 15 squared plus 5 squared plus 15 squared. So I have 15, 15, 5, 15. So I'm here, so I have 15 and 5 again. $18.25. Okay, I just want to check. There's so many repetitions. How many 15s? I have 1, 2, 3, 4, 5. So I have 5 times 15 squared. And then I have 1, 2, 3, 4. So I have 4 times 5 squared. And then I have a 25 squared. Okay. Is that right? Oh, okay, just need to check my calculations again. So I have 15 squared, 15 squared, then I have squared. Okay, let me just count them again. So it's 1, 2, 3, 4, 5. So 5 15 squareds. And then the fives, and how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the fives, there's 1, there's 2, there's 3, there's 4. Okay, and then the last one is 25 squared. So here I'm getting 18 50. So I'm hoping this is the correct one, but just check in case I made a mistake. Even this one here, how many 2s do I have? 1, 2, 3, 4, 5. 2 squared, there's 5 of them. And then I have 8, there's 2 of them. And then there's an 18, so that's 7, 18. And then there is 12, so there's 2 of them. Okay, so that one is fine. Okay, so now I have my values for these two. Then all I need to do is substitute them into the formula. So R, this is equal to, here is my formula. There. So this is 900 divided by the square root of 760 multiplied by 1850. So on calculators. Uh-oh. We have 900 divided by the square root of 760 multiplied by 1850. Okay, and this gives us 0.7590. Okay, so this gives us that. Okay, and then of course you saw that I was entering the data in the calculator. The calculator can actually work out the R, your correlation coefficient for you. So you just say shift that, and then we go to regression, number 5, and this is number 3. And there it is. And that is exactly the same way that you did it. So if you know how to enter this onto the calculator, and then you see that the question is just like 2 marks, why go through all this long process? You can just do it on your calculator and get your correlation coefficient instead of creating this long table. And you can see, even for me, it's very easy to make a mistake. Okay, so that is how we work out the correlation coefficient. And then we can always go back. Our correlation coefficient is 0.7. What does that mean? So we look at our values over here. So it is more than 0.7. So here. So our correlation coefficient, the absolute value, is equal to 0.759, which is greater than 0.7. And how do we interpret that? What does that mean? It means that we have a strong positive correlation. So we have a strong positive correlation. Okay, so it's positive because even before I take the absolute value, the answer is positive. And we could see from our scatter diagram, here's our scatter diagram. So when we drew the data, it was here that we have, maybe the graph is not that clear. So a scatter diagram is not necessarily the best, but to give you an idea that we do have a strong positive correlation. So we could already see that it was positive, but when we calculate our R, then we have like a more definitive answer. And the last part of this chapter is what we call coming up with a linear model, or yeah, we're coming up with a linear model. Okay, so using regression analysis. So we say here that in regression, the relationship between y and x is modeled in the following form. So we have y is equal to b naught plus b1 times x plus epsilon. So y here, this is our dependent variable, and x is our independent variable. So if, for example, we're still looking at the example of income and IQ, we want to see income is it dependent on the IQ that the person has? So B naught would be our y-intercept, and B1, call this the coefficient, but this is our gradient. This is the coefficient. And then sigma, not sigma, epsilon. So this is a Greek letter, epsilon. Okay, and this is an error term for each observation. And for you guys, we are not going to look at finding out what this error term is because there is no additional information that is given. So we're not going to look at that. So we'll only focus on this part over here. Now to work out B naught and B1, we have a formula. So a little bit complicated. So it's very important that you just use your calculator, okay? Remember the formula and then use your calculator to get each of them. Of course, you can use your table to work out each of them. So you can see that you first have to find B1, and then you are going to use B1 in order to work out B naught. So if your B1 is wrong, then it means that your B naught is also going to be wrong. Okay, so let's see. Here's an example. So we're told that in the table, the first two columns gives the value for the birth weight in ounces and the increase in weight between 70 and 100 days expressed as a percentage of the birth weight Y in 12 infants. Plot a scatter diagram. So this is the data that we are given. So the plotting of a scatter diagram, I don't expect anybody to have any problems, but basically what I want to see is you have to show your x-axis here and your y-axis, and then you label them. What is my x-axis? So x, this is the weight, and y is the increase. So this is our weight in ounces, and this is the increase as a percentage. Okay, then you come up with a scale. So if we look at our x's, so they go from 80 to like 120 almost. So you can start somewhere here. So usually we do that to show that we're not starting at 0. So this is 80. Okay, let me copy to the other one. It's easier to draw there. Okay. So like I said, we have our x and our y-axis. So this is the weight, and here is the increase, or the weight increase in percentage. Okay, so we write something like this to show that we're not starting at 0. Then you can have 80, 90, 100, 110, and here we have 120. So it's better on graph paper, then you can see clearly what the correlation is. And here our increase, the smallest one is 40, and then it goes up until 120. So we can count maybe in 20. So we have 20, 40, 60, 80, 100, 120. Okay, and then we plot each of these points. So on bigger graph paper, of course, you will be able to draw a much better point. So the first one, we have 112 and 63. So maybe that is somewhere there. It's not going to be perfect. Then you move on to the next one. We have 111 and we have 66. So it's maybe somewhere there. And you just keep plotting them like that, no matter where they fall. And then eventually you'll come up with your scatter diagram. So I'm not going to do that one because that is fairly easy to do. You should be able to do it. So just make sure you have a nice scale on the x-axis, nice scale on the y-axis. It's better if you even have graph paper, then you can clearly plot out the points. So I have one here that is done. I think even in Excel, you can generate a scatter plot and then check if what you got is correct. So this is an example of what it will look like. So please do try on your own, draw it, and this is what you have. So here we can see that there is some type of correlation, and it is a sort of negative correlation. Maybe not so strong, but there is definitely a negative correlation. The line of best fit would go in that direction. So there is a correlation. Okay, so this one I just put this in ChatGPT and it came up with it. Right, so then that was the first one. Then it says fit a regression model. So when it says fit a regression model, what that means is you need to come up with an equation. And the equation you are going to come up with is the equation that's over here. This equation, y is equal to b naught plus b1 x. Sometimes we have a and b, same thing. Whether we use a and b over here, it doesn't really mean anything. And even in your calculator uses a and b. But basically, we want an equation y is equal to. So we want the equation y is equal to not. We are not going to look at the error term. So this is all we are going to look at. So we said first you need to work out your B1. So B1, this is the sum of x, y minus the sum of x, the sum of y. This is divided by n over the sum of x squared minus the sum of x squared over n, okay? And b naught, this is y bar minus b1 x bar. Okay, so like I said, as you know, there's like two ways of doing it. We have the long way and we have the short way, which we do on our calculators. So I'm going to show you both of them. Let's put our data back. Okay, not this one. I want to copy this table again. Is this? No, I cannot. Okay, so looking at what we need from our table, you can see the totals here are already given. This is the sum of x, so it's equal to this one. This is the sum of y, it is equal to that one over here. So we need a column x times y so that we can work out the sum of x, y. Okay, and then we need a column for x squared so that we can work out the sum of all the x squared. So these are the two columns that we need. So here we multiply them. I'll try and do this quickly. So we have 112 times 63, this 7,056. Then 11 times 66. Okay, so this is what I have. So hopefully I haven't made any mistakes. Then what you do is you take all of these and you add them together. So you have 7,056 plus 7,326 and so on. Okay, so I got 94,322. So this is my sum of x, y. Then we need the x terms to be squared. So we have x squared. So we say 112 squared. 12 squared. This is 12,054. 12,500. 12,000. And we fill up the rest. And then you can work out the sum of all of these. You just add them together. That is what we get. So this is the sum of x squared. All right, then from there, it's just a matter of substituting into our formula. We know that B1, this is equal to the sum of xy minus the sum of x multiplied by the sum of y divided by n. And this is divided by the sum of x squared minus the sum of x squared over n. So on calculators, we substitute. So at least I would want to see that you know what these values are. So the sum of xy, this is 94323 minus the sum of x. This is 1209 multiplied by 975 divided by n. N is how many points we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we divide this by the sum of x squared. So this is 1, 2, 3, 5, 6, 1. Minus the sum of x squared. So the sum of x is 107. You square it. And then you divide by 12. So on our calculator, we would have 943 minus 9 times 95 divided by 12. And this is all divided by 1, 2, 3, 5, 6, 1 minus 1207 squared divided by 12. Okay, and here, why am I getting a number that is more than 1? Let's see. No, it's fine. I think I see the mistake I made here. I wrote 1209, but it should actually be 1207. Yeah, there it is. Okay, so when we type it into the calculator, we get negative 1.737071. Okay, if I write to 4 decimal places. So A and B are not necessarily restricted, or B1 and B0 are not necessarily restricted to being between 0 and 1, because these are your gradient and your y-intercept, so they can be any value. Okay, but we have B1 here. This is our gradient, and we know a negative gradient means the slope is going down. So after we have our B1, then now we find our B0. So B0, if we remember our formula, y bar minus B1 x bar. Okay, so y bar, we just take the total of all the y's and we divide by 12. And of course, this you can always just do on the calculator. So the total of all the y's is 975, and we divide this by 12. This gives us 81.25. So we have y bar. So we then substitute here, we have 81.25 minus negative 1.7371. And then our x bar, we just take this one here, x bar. This is one. It is the total of all the x's divided by 12. So 17 divided by 12. And that gives us 100.5833 and so on. So multiply this by 100.5833. Okay. So on our calculators, we then have 81.25 minus negative 1.7371 multiplied by 100.5833, and this gives us 255.977. Okay, so now that you have found your B1 and your B0, then you now just write the equation. Okay, so this is our B0. Okay, so we write our equation, and the equation is y is equal to B0 plus B1 multiplied by x. So it's over here. Here's that. So you can see the table here is completed for us. Where's the formula? The formula is here. B0 plus B1 times x. And for now, we are not going to look at finding this error term. So we just write our equation. So we have y is equal to, what is B0? 255.973 plus B1. This is negative. So it's negative 1.7371 multiplied by x. So that is our regression line. Okay, so our regression model. Then now the last part says, if the birth weight is 95 ounces, predict the increase between 70 and 100 days of life. Okay. Now, since it doesn't give us specifically when exactly, at what value. So remember X, okay, no. So we want the birth weight, sorry, the birth weight is given at 95. So we have write down our equation. So we have Y is equal to 255 point 0.973 minus, we have 1.73. 1.7371 times X. And remember here, X is the birth weight. So we are told that X is equal to 95. So we're going to substitute 95 here, and our Y is going to be our percentage increase. So we have 255.973 minus 1.7371 times 95. So we have our calculator again. We have 255.973 minus 1.7371 multiplied by 95. And this gives us 90.9485. Okay, so this is the percentage increase. So it's this one. Okay, so if we then look, the example has been completed for us here. You just need to check and see if what is done corresponds with what we have. So our table of values, they look like they're matching. Let me just see here, where is our table? Okay, so we have our XY, which is 94322. Let me see what we have in the notes. Okay, that's fine. Then the summation of the X values. Sorry, is it XY? Summation of the XY, summation of the X squared terms. X squared terms 1, 2, 3, 5, 6, 1. So you can see there it is. This one here didn't work it out because we didn't really use it in our formula. So there's really no need to work it out. Then that was it. The next part was just to substitute into the formula. So I believe this is everything we got. So here we have 100.6. I guess it's the rounding off. Let's see, what do we have? So I have 100.5. So in the notes, it's just rounded off to 1 decimal place. So that's also fine. And then Y bar is 81.3. What did we get for Y bar? So again, this one was rounded off in the notes, but we can see we're getting the same answers. Then our B naught, because of the rounding off here, it affected it a little bit. So in the test, I'm not really going to be too strict about the actual value. If I can see that, okay, I got 100.5 6, which is 100.6, and you got 81.3, and I got 81.25. Those are essentially the same. So I'm not really testing you on rounding off. I'm more testing you on do you know how to work out these values that we are looking for? And then the last part was just after you found your B naught and your B1 to substitute the 95 into the calculation. So when we worked it out, we got a percentage increase of 90.94. And this is very close to that. Again, there's a slight difference. It's completely different than if somebody got like 50. 50 is very far, but somebody getting 90 and another person getting 91, you can see that the rounding off, of course, affected it a little bit. Okay, and that is the end of this chapter. This is basically what you will be asked in the test. But like I said, all of this we can do on our calculators. We don't need to draw our tables. Basically, what I want to see is, are you able to we want to do this on our calculator. So again, you would go to stat mode and like here, shift mode, go mode, and then you go to stat mode, and then you click option number 2, then you'll start entering the data. So here, since I've already entered the data, there it is. So you'll go to your data, you just go here. So you have enter your X values first, 112 equals 111 equals 107 equals, and so on. Then after you're done with all the X values, then you just use your right arrow there, go to the Y values. Okay, and you enter them. Then you press on, and then all of these values that I have been working out, B1, B0, you can even work out the correlation. You can get them straight from the calculator and you can check if what you've done is correct. So we shift stat, then we go to regression, number 5. A, this is your B0, so this is 1. And you can see there it is, 255.971. And then again, stat number 5. If we want our B here, B is the B1. Press number 2, and there it is, negative 1.7370. And then we can also work out our correlation coefficient. Number 5. This is 3. Okay. And there it is. So you can see there is a high negative correlation. So when we looked at our graph, where was it? Our scatter plot. This was our scatter plot. You can see you can almost draw a perfect line there. There is a high negative correlation. Okay, so with the calculator, basically what I will be checking is, did you get these values? Did you get the sum of the xy? So you should write that down, the sum of the x's, the sum of the y's, and the sum of the x squared. And also, what is your x bar? So these are the ones that I'm looking for. So which you can just do on your calculator, and what is your y bar equal to. Okay, so that is what you can do very easily on your calculator, because you go shift, stat, and then the sum 3. So there's number 1, which we look for. It's this one here. Number 2 is this one here, sum of x, y is number 5, and so on. So all of this you can do without drawing the tables, which can take quite a long time, and it's very easy to make a mistake.